Okay, so let's discuss the Floyd Warshall algorithm, where again, we're going to use recursion to solve the shortest path problem, except in this case, we're going to use a slightly different recursive idea to formulate a new recursive algorithm. So let's go and define a new recursive function, the distance from I to j, where and index k. Okay, so what do we do? What does this mean here? What is this k here? Well, in the Bellman-Ford algorithm, we said that we reduced the problem by saying that first we're going to find the shortest path using one edge, then we're going to find the shortest path using two edges, then we're going to find the shortest path using three edges, then we're going to find the shortest path using four edges. Okay, so that was the idea behind Bellman-Ford. With Floyd Warshall, the idea is slightly different. First, let's just number all the vertices. Let's just number them 0 to, or let's number all the vertices like, 0 to n minus 1, whatever. Okay, so how about instead of number of edges, we say we're going to find the shortest path using vertices. First, only using vertices 0. Then we're going to find the shortest path using only vertex 1. Oh, using only vertex 0 and 1. Then we're going to find the shortest path using vertices 0 through 2. Then we're going to find all the shortest paths using vertices 0 through 3. Then we're going to find all the shortest paths using vertices 0 through 4, and so on, right? So instead of saying that the shortest path depends on the number of edges, we're saying that the shortest path depends on a subset of vertices. So we make the subset small, and then we go to a larger subset of vertices until the point where we find the shortest path using all the vertices in the graph. So that's the idea behind the Floyd Warshall algorithm. So we define this function, distance ijk, where the distance from vertex I to vertex j, where it's the distance from vertex I to vertex j using the vertices 0 through k, or 1 through k if you're using one indexing. Yeah, you're using one indexing. Okay. So what is the distance from I to j if you're using none of the intermediate vertices? And the distance is 100, right? It's this edge right here. Okay, so what's the distance now if you're using only the vertex 1? Well, the distance becomes, if you're using vertex 1, then you have a new path. The path is basically the distance from I to 1 using no vertices, and the distance from 1 to j using no vertices. Okay, and in this case, we have a nice little path here that gives you 9. Next, what's the distance if you're only using vertices 1 and 2? And the answer is you have a path that goes from I2 to 2, 1 to j, and that is of length 8. And similarly, if you include all the vertices, then you could finally get a path of length 6. Okay, so that's the major idea behind the Floyd Warshall algorithm. But how do we calculate? How do we calculate the function? Oh, it's length 5. Sorry, it's length 5. I made a mistake there. This is the shortest path. Anyway, how do we actually calculate this function? Okay, and for the Floyd Warshall algorithm, we simply say that the distance from I to j using at most vertices 1 through k is the minimum of either the distance from I to j using the vertices 1 through k minus 1, or it's the distance from I to k using the vertices 1 to k minus 1 plus the distance from k to j using the vertices 1 to k minus 1. Okay, so you see this recursive function. And again, you have the base case where the distance between I and j using no vertices is simply the length of an edge if it exists between I and j. And otherwise, it's infinity. So that's the base case. Okay? So if I can reach k and k can reach j, then the distance k to k times k minus 1 is less than 0 if g has a negative length cycle containing k. And the distance ij comma k is negative infinity. Okay? So the recursion below is only valid under this condition. So we can detect if there is a negative length cycle during the algorithm, or wait till the end to detect if there is a negative length cycle. Okay? But that doesn't really change the Floyd Warshall algorithm once. It just means that we have to observe, we have to be on the lookout for negative length cycles, for the cases where the distance from a node to itself can be less than 0. If that happens, then it means that there is a negative length cycle somewhere. Okay, so that's the explanation of Floyd Warshall algorithm. We'll go over the actual algorithm and running time next.